Hello problem solvers. So here is another inequality. You can please have a try. So this is a common condition. You somehow need to apply it. So one possible way would be, so this is not the solution, but it's just what I've tried. Okay, you can skip over this part if you want. So if I multiply yc top and bottom, right, I can change this to x squared because xyz equals 1. But then later, so as I normally, if you have a fraction, it's very common that you have to apply the Tito's lemma. Let me put it here. So because you have a fraction, okay, not many inequality have fractions. Yeah, so this is the Tito's lemma. It's very common to use whenever you have a fraction. But if the top looks great, right? It's a square, but the bottom, if you try to apply Tito's lemma, okay, the right hand side, so this is just one term, right? But when you are trying, when you are exploring, you don't have to write out everything. So let's say this is the left hand side, then it will be equal to sum of xyz square divided by the sacred sum of this. And if we can prove that this is bigger than 3/4, then we will be done. However, we have done a bad thing here. What is that bad thing? You see at the top, this is degree 2, where x squared, so all the terms have degree 2, but in the bottom you have, if you multiply out, the terms have degrees at least 2. So if I want to prove this and I multiply this to the right hand side, this to here, then I want to prove that the left hand side bigger than right hand side, but you have a degree 2 here, and you have some degree 2, degree 3, degree 4 here, and that would be very hard to do. Right? Things probably won't work out this way. So immediately you kind of know that this approach wouldn't work. So as I said, that is not the solution. So, but when you are learning, it would be great if you have this kind of things in mind. Okay, you immediately know that direction is not going to work, then you can try another direction. Yeah, so that is my whole purpose of doing this channel. I think if you just read the solution, or if you just watch other people's solution, like other YouTube's channel, it's not that educational to you. Like, you have to really learn these things that are invisible in the solution. That's the analysis part. Anyway, let's start solving this problem. So again, I would like to apply Tito's lemma, but the top is not a square, and so you need to multiply by xe. Okay, so and then of course you need to multiply top and down by xe. So let me write it in cyclic notation. Cyclic notation just means when I do something for x, y, x, it means for y and z as well. So this sum is not the same as symmetric sum. Secret is just one cycle x, y, z. So secret means this works for x, y, z. Okay. And then I apply Tito's lemma. And in the top, I have this. In the bottom, I will have cyclic this. So now I just need to prove this. And you see, in the top, I have degree 4, right? X is 4, y 4, z 4 plus 2 times x squared, y squared, okay? The terms have degree 4. And here, the term has lower degree, right? The highest degree is 3, x, y, z, which is actually 1. So the highest degree is only 2. And that is the good thing. That is the direction you want to move to. So now let's just expand, okay, everything. So I like to write this in this format. This is not a vector. It's really just a short-term notation. I don't like to write out very long. So this is just my way of writing stuff. So it's easier to see. Okay, so if you expand this and multiply by 4, you get 4x 4, 4y 4, 4z 4, plus 8 of this, 8 of this, plus 8 of this. But I just write it this way. It's not a vector. On the right hand side, if you expand this, you get xe plus xy plus xz plus xyz, and you have a cyclic of this. So you have the y version, you have the z version, okay? But altogether you have xyz, and then xy will appear twice. So are the other terms. Right, this is the bottom of this. So remember, you have multiplied by 3, so altogether you have 6, and I have 3 xyz here times 3, I have 9 xyz here. Okay, so we just need to prove this scary looking inequality. But before we do the actual calculation, okay, one thing to make sure you're on the right track, you didn't make any mistake, is to make sure you have the same coefficients. So let's say, well, doesn't always work like this, but in this, you see, probably the equality holds when x, y, z all equals 1. You can check that. So when they are all equal, the inequality should work. And that means if you just change all of them to 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, this should be equal. Okay, so that is a quick check if you have calculated these coefficients correctly. So if I just substitute everything to 1, I get 4 times 3, 12, 8 times 3, 24, so altogether 36. here 9, 18, 9. So 36. So the coefficients seems to be balanced. Okay, and that is what you want. Okay, so let's start proving this inequality. Of course, the degree, you have higher degrees, so somehow when you do the inequality, you have to use this condition to eliminate the degrees, right? If you have, so for example, if you have x, y, y squared c, then that just means y, right? So somewhere along we need to make that we need to do some elimination. There is an inequality called the Merhetz inequality that you probably can apply here. What Merhetz says is that it basically says that whenever you have symmetric polynomials like these, and if the coefficients are equal on both sides, and if the left hand side has higher degrees, then it is bigger than the right hand side. Okay, that is not a very formal statement again, but it will take quite a long time to explain. You can read it online, of course. Okay, it talks about dominant terms, or you can treat it, you can think of it as higher degree. So that's why I said at the beginning, you want to have higher degrees on the bigger side. So that is like at the back of your mind, you know it will work. You just have to actually carry out the calculation. And this is a very it's not, well, it is quite common that you can reduce inequality to something like this, and you just do the arithmetic as I will show you below. So so again, I keep saying you want higher degrees. So these are the best terms because they are the more say homogeneous, right? If x, y, z are not equal, then x4 will, let's say x is the maximum of x, y, z, then x4 is biggest. x4 will be bigger than all of these, right? So these are the more precious terms. Okay, these are not as precious as these, so you have to treasure these. Okay, so it would be great if we can use these to show that these terms are bigger than these terms, and then if we can use up all of these, then in the end it will make our job easier. So that's what I've done. So you can try some experiment. So for example, let's see if I have x squared y squared plus yz c squared. Okay, I just take these two terms, apply AMGM, so that will give me 2xyz squared, and as I told you, that is 1, that is y, so this becomes 2y. Okay, great. I take these two guys and I make 2y. I need 3. I need 3y here. I need a 3 here. So let's just multiply everything by 1.5. That means 1.5 of these will give me 3 of these. Wait, that is, let me make So then if we just swap these to x squared y squared and c squared x squared, then I will have xe here, 3xe, and so on. So so imagine I have, let me just write it out for you. X is c and x is y, let's say. Then I will have 3xe, and you can see the third one, yc, xc. Okay. So, and altogether, x squared y squared 1.5 of 1.5 copies of x squared y squared and 1.5 copies here. So altogether I have used 3 copies of x squared y squared and 3 copies of this, 3 copies of this. So this becomes 5, but this is gone. Okay. Let's try to find out how to get xy. You have to experiment. Well, actually there is a mechanical way, but it's way too complicated. Usually I just try it out. So it turns out if you have x4, I need 2x4, 2y4, and x squared. Okay, turns out these 6 terms. Apply AMGM. So x power is 10, y power 10, and z power 4. But you know xyz is 1. So cross out the power 4. Okay, and that gives you 6xy. And here, so of course you apply the same thing to xez and yez. And altogether I have used 4xe4, like 2x4 for here, and then for xc you need 2x4 here again. So altogether you have used 4x4, and similarly 4y4 and 4z4. That means you have used up all of these, and you get all of these. Okay, and I have used 1 copy of yc here, and then 1 more copy of yc here. That means I've used 2. Originally after this it was 5, now reduced by 2 again, it becomes 3. So you are left with 3 of these. You need to prove that there is at least bigger than 9 xyz, but that would be very easy. So basically then you just add up everything. So to quickly write out everything, this would be xc, y and yc. This is 6yc, so x squared y squared x squared z squared. Okay, if you add up, so altogether you have 3 of these and 9 of these. So finally you say this is the easiest because all the terms are the same, all the terms have degree 1. So you just use anything that is left. Okay, usually the leftovers will work. Okay, AMGM again. XE4, Y4, C4. Or you can just make it 1. I'll make it XYZ is 1. So that is 9. And then this would be 9. Okay. And that is 9 as well. So that means if I add up all these inequalities, I will get these. And that's the rest of this solution. So let's reflect. Again, the inequality has a fraction form, so it's normal to try out Tito's lemma, and we just need to prove this part, and I try to explain that this will work using Merheads. You just need to figure out the appropriate coefficients. So for example, 1.5 of this, 2 of this. Okay, you will have to do some experiment yourself. Okay, but then all of these are just AMGM, just adding AMGM, right? AMGM, and that would gives you, that will finish the solution. So it is, if you have never seen this technique, this would be quite it's quite hard to come up with these, but that is a useful technique. Just experimenting with the terms and then crossing out what's work, crossing out the terms you are done, just step by step getting all these terms on the right hand side. Okay, very common technique. Okay, and also of course Tito's lemma, always try that when you have fractions. Okay, finally let's have the difficulty score. I would say, because it's not so original, but it's difficult, I think it's appropriate to give it a 7 out of 9. So it is at the it would be a difficult question on the National Mathematical Olympiad level, and the character for this level would be Kakashi. It's almost, Kakashi is like the S rank, right? S rank in Naruto. Anyway, thank you for watching.